Listen, I misspelled a word. Okay, but you know what? We're going to go with it. We're going to roll with it. So you may be wondering, well, what is the law of definite proportions and the law of multiple proportions? Well, let me kind of explain this to you in simple terms. It helps us understand how chemical compounds and their consistent composition is crucial in the fields like forensics and healthcare, especially when you're talking about medications and products that were found that were illegal. Okay, you want to know what I'm talking about? Keep watching. So the definition of the law of definite proportion states that a chemical compound always contains exactly the same proportion of elements by mass, no matter the size or source of the sample. So for instance, if we were looking at water, you know the formula for water is H2O. It always has 2 hydrogen atoms and 1 oxygen atom. By mass, water is always composed of 11% hydrogen and 89% oxygen. Now, why is this important? Read that little statement right there, okay? Now, when we talk about the law of multiple proportions, it states that when 2 elements form more than one compound, the masses of one element that combine with a fixed mass of the others are in a simple whole number ratio. So what do we mean? For instance, if we have carbon, we know that it can combine with oxygen to form 2 different compounds. Carbon monoxide versus carbon dioxide. One's going to keep you alive and the other one's going to do what? Peace you out, okay? The ratio of oxygen and carbon dioxide to oxygen in CO is simply 2-to-1. That's a 2-to-1 ratio, okay? Let's keep it moving. So let's take a look at this example here. It says a suspect is caught with 2 samples of an illegal substance, y'all. Sample A contains 14 grams of nitrogen and 32 grams of oxygen, while sample B contains 28 grams of nitrogen and 64 grams of oxygen. We want you to prove that these samples are 2 different compounds based on the law of multiple proportions. So you see, in forensic chemistry, this law is applicable. Stay tuned. So how do we solve this? Here we go. Sample A contains 14 grams of nitrogen and 32 grams of oxygen. We told you that. So all you have to do is put the ratio of nitrogen to oxygen. So you're going to take the sample A and say it's a 14 to 32 ratio, or reduce it down to 7-to-16. Now, how do we reduce it? Because we divided both numbers by the number 2, and 14 divided by 2 gives you 7. 32 divided by 2 gives you 16. Okay? Sample B contains 28 grams of nitrogen and 64 grams of oxygen. Same thing. The ratio between nitrogen and oxygen is 28-to-64, or 7-to-16. Again, you're dividing both numbers by the common denominator, or the common multiple, in order to get the ratio of 7-to-16. And since the ratio is the same, guess what, y'all? The 2 samples are the same compound, okay? This suspect is what? Busted. If you want to learn more about doing problems like this, come join my lives Monday through Thursday at 12 noon Eastern Standard Time, and on Tuesdays and Thursday evenings at 7 p.m. Eastern Standard Time. If you want to be live and get all this goodness, y'all, come holler at me. Pull on up, because you're going to be in for a treat with Professor TK, the Chemist.